Hello everyone, welcome to Science Roots. This is Professor Vishal Maitre, working as Assistant Professor in the Department of Electrical and Computer Engineering at Bharati Vidyapeeth, deemed to be University College of Engineering, Pune. In today's lecture, we are going to discuss about the apparent power, active power and reactive power. So first let us understand the basic concept that needs to identify what different types of powers are there. Before going into that, we need to understand there are three different kinds of circuits. One is resistive circuit, second is inductive circuit, and third is the capacitive circuit. So in resistive circuit, voltage and current are always in phase. So angle between them is 0 degree. Second is inductive circuit, where current lags behind the applied voltage by certain angle phi. And third is the capacitive circuit, in which current leads the applied voltage by angle phi. Now the reason for considering the inductive load is, in most of the practical applications, the loads that are actually connected are inductive in nature. So for understanding this type of power, I have considered the inductive circuit. So as discussed, inductive circuit is the circuit in which current lags behind the applied voltage by certain angle phi. So accordingly, phasor diagram is considered, where V is the applied voltage, that is the reference, and I is at a certain angle phi. So resolving this angle phi into horizontal and vertical components, that is the fundamental law of physics. So its horizontal component is I into cos phi and the vertical component is I into sin phi. Now this is very helpful for considering the important concept that we call it as power triangle. So the diagram that we have considered, I have drawn a triangle which can be highlighted in the bold lines, where you can find current I, the total current I, the vertical component I into sin phi, and the horizontal component I into cos phi. Simple, this is like a current triangle where only the values of current are there. And to each side, if I multiply by voltage, I will get this I becomes V into I into sin phi becomes Vi sin phi, and I into cos phi becomes Vi cos phi after multiplying voltage to each side. So this V into I represents the apparent power, V into I sin phi represents the reactive power, and V into I into cos phi represents the true power, or it is also called as the active power. So this type of powers, it is not only applicable for inductive circuit, but the same type of power can also be calculated considering the capacitive circuit. So let us understand what is this active power, apparent power and reactive power. So first let us understand what is apparent power. So the total power that appears to be transferred between the source and load is called the apparent power. So for example, whatever the electrical appliances that we connect, whether it is CFL, LED bulbs or fluorescent tube lights, fans, all these are consuming certain power to give the output. So that power is the apparent power. So it is equal to the product of voltage and current. So apparent power is V into I. So its unit is, for V it is volt, I it is ampere, so it is VA. So it is sometimes rated as kVA, that is kilovolt ampere, or MVA, that is megavolt ampere. So depending on the ratings, it is decided whether it is VA, kVA or MVA. So another important thing is apparent power is further divided into two components. One is true power or active power, and another is the reactive power. So let us understand the next important part of the apparent power. What is the active power? So active power is the actual power that is being consumed in the circuit. As mentioned, whatever is the electrical appliances that are connected, they are consuming the power to give a certain output. Those are called as active power, or it is also mentioned as true power. So the power is consumed in resistances only. Power is not consumed in inductor or capacitor because the average value of the power in inductive and capacitive circuit is 0. And as we know that current and voltages are in phase for resistor circuits, so current in phase with voltage that produces the true or active power, and that is the reason why it is called as the useful component of apparent power. So there is one more definition of active power, that is the product of voltage and the component of current, that is the horizontal component of current, that is I into cos phi. So the product of voltage into the horizontal component of total current, I into cos phi, that is P equal to VI cos phi, that is called as the active power. So active power or true power is denoted by capital letter P, and its unit is watts, denoted by W, kilowatts by kW, or megawatts by MW. Similarly, reactive power. Now this is very interesting to know that reactive power is not consumed. So how it is different from active power? So reactive power is neither consumed nor does it do any useful work in the circuit. That is called as reactive power. Then what is the use of this reactive power? That is the question comes in front of everyone's mind. So the power consumed in inductive and capacitive circuit is 0. The reason is power received from the source in one quarter cycle is returned to the source in the next quarter cycle. So in this case, whatever is the first quarter cycle and returning immediately to the next quarter cycle, the average of it becomes 0. And that power is the reactive power whose value is 0, but it is present in the circuit. So it only goes to and fro in the circuit. It is nowhere consumed, it is nowhere used, but its presence is very important. So the definition of reactive power is that the product of voltage and the vertical component, that is the out of phase component we call I into sin phi, is called the reactive power. So Q is the notation that we use for reactive power, is given by the product of V into I sin phi. So its unit is volt ampere reactive, VAR. It might be kilovolt ampere reactive, kVAR, or megavolt ampere reactive, MVAR. Now very simple concept to understand that what is the different types of power. So as you can see, there is one chips packet, potato chips packet, where the entire packet contains chips in it along with some gas present in that particular packet, and it is completely sealed. So the sealed packet, which contains air along with chips, that represents the apparent power. The reactive power, that is the gas, it preserves the crispiness of the potato chips. So its presence is very important to maintain the crispiness in the chips. So that is why it is reactive power. And the actual chips that are going to be consumed is the active power. So reactive power usefulness is it maintains the frequency in the system. The frequency followed in India is 50 Hertz. So the purpose of using this reactive power is to maintain the frequency close to 50 Hertz. At real time basis, it is never 50 Hertz, but it is the duty of the reactive power to maintain the frequency in the entire system. Related to this, active power, reactive power, and apparent power, there is one more concept, that is power factor, that we will understand in the next session. Hope this was easy for you to understand. In case of any query or any suggestions, you're welcome to post your queries or any suggestions in the comment section. Thank you. See you in next session.